Hello and welcome to a Prismatiscape adjacent video where we're going to be talking about pivot painting and how I utilize it in the Prismatiscape plugin. We're also going to go over my pivot painting script and how you use it for, different types of foliage, and also how my script differs to the classic Unreal Pivot Painter 2.0 super complex where it generates a texture for each thing. It's a big fucking mess. So let's straight away jump into it. The first thing to kind of talk about is what is pivot painting, because I feel like that word gets thrown around a lot. So we're going to start off here in MS Paint, and imagine we have a group of verts. Let's just say this is a leaf, and there's a vert in the middle. So it's these are the edges. We've got verts. 1, 2, 3, 4, 5. And what pivot painting is going to do is essentially tell all of these verts that they belong to this location. So essentially we just say these verts are going to pivot around this location. Now, where do we put this data? So in the Unreal Pivot Painter V2 thingo, they generate a little texture atlas. It's like a 16-bit texture that has a bunch of little pixels, and they put the pivot locations in there as an RGB value. And then they change the UVs to get chucked in to one of these little segments, depending on where the pivot is and whatnot. However, in my version of pivot painting, we don't use any textures. So it means you can use one material instance among, a whole group of foliage. Instead, we just draw the locations to the UV map itself. So if you don't know what a UV map is under the hood, it's basically just for each vertex, it has a two-dimensional value in, a data channel called a UV channel. So the way that I do it is that we just bake the absolute value from the origin of the mesh to the absolute value of the UVs. Because UVs are stored in 32-bit or maybe it's 16-bit, they can go below 0 and above 1. So you can have UVs that are actually all the way out here at 200, 169. It will return that value in the material graph. So with that in mind, we can start to do stuff rotate these fern leaves around their pivot. And we're actually rotating all of the verts. Now, if you think about what I said earlier, you can imagine all of these verts here. I know it's kind of hard to see. All of these verts individually have a reference to this point in local space. And so when we interact with it, we are just saying for each vertex, rotate them around this point, their pivot point. So if we go and look at these ones here, you can see that these big clumps of bushes are rotating around their own individual pivots, even though they're all one mesh. And that's because every single one of these verts in this sub bush has a reference to this position down here relative to its object pivot point. Now, the keen-eared among you may be wondering, well, if UVs are a two-dimensional coordinate, how do you get, things like these leaves rotating around in three-dimensional space? And the way we do that is we actually just pack the RG into one UV channel, and then the Z goes into another UV channel. And one thing that separates my pivot system from other pivot systems, because mine is built from the ground up to work with interactive foliage, we actually paint the root of each group to channel 1, so the root XY. Then we also have the tip XY in another UV channel, and then we put the Z of this and that into a third UV channel. So we use 3 in total for more complex foliage, but that way we have the root location and the tip location in 3-dimensional space. Now, the reason that we want the tip defined is because we want to actually be able to sample the interaction render targets from not the pivot point. So you can imagine something big like this fern. We want it to bend out of the way when we're at the tip of it, or when the tip of it is affected by wind, not just when we're down near the root of it. So you can see here, all of these are, they almost look like they're bonular. They almost look skeletal, but in reality, they are just pivot painted at the root and then also at the tip, which is how we can get more complex behavior from just some, some textures that they're reading from. If you are a Prismatiscape enjoyer or Prismatiscape user, you can now enjoy the full extent of my pivot painting script at no extra charge if you've already got the plugin. So if we go to the Pivot Painter folder, what you'll have to do first is you'll have to run the Pivot Paint editor utility thingo. That's just going to essentially enable it. And now whenever we click on a mesh, right click, scripted asset actions, Pris Pivot Painter, then you can see we've got a couple of commands here. We've got the assign default polygroup layers, and we've got the Prismatiscape Pivot Paint. Now, if you do want to see what this is doing under the hood, it's essentially just some geometry script stuff. Big shout out to Sovereign Dev for showing me how all of this stuff works. He basically gave me the bones of this script, but you guys won't need to worry about this. You're never going to be looking at this part of it. You're just going to be running the scripts. So how do we run the scripts to set things up for Prismatiscape usage? Well, first things first, we find the asset. Let's do something more complex to start off with. So we're going to be doing this one. So we're going to right click on the asset in the browser. Keep in mind you can do this for multiple assets at once. So if you have 20 different variations of the same type of thing, you can just bulk select and right click scripted asset actions, Pris Pivot Painter, and do them all at once. We're just going to do this one for now. So we're going to right click this. We're going to go to the Pris Pivot Painter and we're going to do Prismatiscape assign default poly group layers. We also want to tick secondary is one big fella and click OK. So now if we go into the modeling tools in the Unreal 5 modeling suite, we're going to go down to attributes and we're going to go to paint polygroups. Now you can see in the default polygroup, which is index -1, we have all of our leaves. These are all just generated based on the UV islands of UV index 0. So for 99% of things, this should just work perfectly fine. And then if we go to the next polygroup that was generated, this is they're all just the one polygroup. Now I will show you around just the relevant settings inside here. So there's a tick box down here called show hit groups and also show all groups, which will just show the numbers for each polygroup when you hover over them or when you aren't hovering over them. And then you also want to change action brush to fill, which is just going to fill the entire group that you click on. You also might want to turn on volumetric mode for some other things, which basically lets you paint in a sphere. So if I did this here and erased them all, it's going to erase all of the connected ones that I touched. I'm going to undo that. But for right now, we're just going to be using fill on connected mode, and we've got all our thingos right here. And all we need to do to make something work with Prismatiscape is we need to paint the stem to group 0. So if we hold shift and click, that will remove the polygroup, which turns it into group 0. You could also go set group and set it to 0 that way, but it's quicker to just shift click it. We're going to hit accept. We don't have to worry about the secondary group. We'll kind of go over that later. And now this is ready to be painted with the Prismatiscape script. So let's just get this material here. And we're just going to go into it. This is just one of my debug materials. So we're just going to yeet everything out of it. We're going to go Pris Pivot Data 3D. And we're going to get the gradient. This is just so we can debug what the hell is going on. The gradient is just a gradient from root to tip for each group. So we're just going to hit OK. This will look better in unlit mode. And before we start, let me just unthingize this. Let's just go to UVs and just remove the UVs from this particular model. Okay, now you can see that it is a bit of a mess. So you can see here, this is completely blank. It's, it's all good to go. So what we're going to do, we're going to right click on the asset, scripted asset actions, Pris Pivot Painter, Prismatiscape Pivot Paint. Bam. Now you can see we've got this little dialog box. The polygroup layer index that we're working with at the moment is -1, which is the default. We don't need to auto-gen polygroups because we've already done that. This is just there so that you can quickly do like grass and other small foliage things without having to run both scripts. We do want to assign UV pivots. Bam. The pivot foliage type for this kind of mesh is a bush. You can see here in this drop-down menu, I've got like little, in brackets, what they kind of do. So a bush is 3 UV channels, pivot XYZ, root to tip, radial XY from center. We're going to click that. Starting UV channel is usually 2. All of my material functions are set up to work from channel 2 to channel 4. If you need to change it because you've got data in channel 2 already, then you'll have to go through and change the UV channels that are in the Prismatiscape Pivot Data material functions. Now we can choose to paint vertex color right now. We can also just do vertex color in a separate pass, but for now, let's just do it this way because we're going to be using the root to tip mask the same as the pivots. I'll kind of explain what I mean by that in one of the next foliage examples. If we are vertex painting, if so, what channel? The R channel is the default. Lastly, we've got this use absolute vertex paint distance. So this is like, rather than vertex painting it from the root to the tip with a 0 to 1 gradient, we can paint it from the root to a distance past the tip with like an absolute value, which basically results in smaller leaves being painted darker overall, whereas the bigger leaves are painted, 0 to 1. So you might need to toy around with this a few times. Let's just set it to 80 for now. And we've also got this setting here. This is something that Sovereign told me about, but apparently nanite meshes, their UVs are really fricky. So something that you have to do if you're using nanite is you have to divide the pivot locations by 1,000 and then multiply them by 1,000 in the material side of things. Otherwise, they'll be completely inaccurate. So that's just something, if you are using nanite, you'll probably want to have that ticked. Anyway, we can click OK. That's going to go through. It's going to do its thing. You can see that the pivots have been painted properly. We've got, this one here, root to tip, blah, 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 blah. It looks like all of these have been done really well as well, which is surprising. Sometimes it doesn't work that well. And then if we go back into this material and we get our vertex color and we just plug that into here, then you can see that our vertex color, we might have overdone it with the distance, but you can see that, yes, there is vertex color in the red channel. Let me just put that in for comparison. On second thought, let's just go back into the Pivot Painter. This time we're not going to assign UV pivots because we've already done that. We're going to use bush mode. We are going to do vertex paint yes. And we're just going to do this down to like 60 units. So that will just go through and only vertex paint it instead of assigning the UV pivots. So if we switch this back to the bush WPO example, now if we hit play, then you can see that, you know, this is acting very good. It looks great. It's interacting with our textures based on the tips of the leaves. Reacts with the wind, you know, individual leaves react to the wind, and also just overall, the whole thing reacts to wind. And it was that simple. It only took us 5 minutes, but remember, you can do this in bulk. So let's go through another example of some more complex assets. Let's take these little fellas here, for example. All right, so we've applied our debug material to these fellas. You know what, let me just delete the data first. Okay, so for something like this little foliage here, what we want to do is we probably want to pivot paint it from root to tip per clump, because we don't really care about the individual rotation of each little leaf. The other thing about my pivot painting script is that it doesn't deal with hierarchical pivots the way that like a texture-based one works. So our maximum hierarchy is if it's a single stemmed bush that has a single level of branches that we want to be interactable. Anything beyond that, like trees and stuff, isn't going to work with this pivot method. The reason we can do one level of hierarchy is because we can presume that... Where's the button? Is because we can presume that the initial rotation point is the object pivot point. And then we can rotate the other pivots around that pivot, which we'll get into in a little bit. So back to this foliage here, we are going to right click on the asset. We're going to go scripted asset actions. We are going to do assign default polygroup layers. Secondary is one big fella, yes. And now we go to modeling tools, paint polygroups. And first thing we do is we zero out the stems in group number default. So we're just going to go to the stems. We tell them all to get the freak out of here. Bam, bam, bam. Oh, there we go. So that's all of the stems painted out. And then we want to go into the secondary group. And we actually want to paint each clump of these in its own group. So we're going to go to the volumetric mode, like this. And you can just press Shift Q to select a new group. And we're going to paint everything, including the stem, to be this group for this, you know, this clump. Just going to make sure I get all of them. Otherwise, this will not work. Cool. Shift Q, next group. Go here. Da-da-da. Cool. Shift Q, next group. Do that. Painting number 4. You get that. That's all good. Shift Q again. Bam, bam, bam. And Shift Q. Last one. Bam, bam, bam. That looks pretty good. All right, we hit accept. So now if we right click this asset, we go to Prismatiscape Pivot Painter, we go to the Pivot Paint script. We want to do our pivots in group number 0, which is the second one. So -1 is the default, 0 is the first extended polygroup layer. We do want to assign UV pivots, and we want to assign these as clumps, which means that it's just going to do it from bottom to top rather than middle to out. Starting UV channel 2, we don't want to paint the vertex colors. We'll get into that right afterwards. And that's all we need to do. So we click OK. That's going to pivot paint these from root to tip. So you can see our debug gradient is correct. So now it's time to do the vertex color for these clumps. But we don't want the vertex color to be from root to tip. We actually want it to be the individual leaves. So we're going to right-click, Pris Pivot Painter, Pivot Paint. We're going to use the default polygroup layer, which is the one where all of the leaves have their own group, and we painted the stems to 0. We're not going to assign UV pivots. We're going to paint this as a bush, which is from middle to outer. And we're going to paint vertex color, yes, in the R channel, and then use absolute vertex paint. We'll do like a 25 unit. So if we hit OK, you can see that this actually goes through and paints the stems to 0, and then the leaves that are coming out of the stems from 0 to 1, or, 0 to higher than 0. Because we're using an absolute distance, then the smaller leaves get painted darker, which means that they're going to flop around less when we, apply wind to them. So now if we go back to these and we go to the WPO example medium clumps, or maybe these were flowers. And now if we go to these, you can see that they all rotate independently of one another, even though they're all in the same mesh. And then you can also see that the leaves, they kind of wiggle around because they are vertex painted. So you can kind of use vertex paint as like a secondary pivot by just moving the verts around, but multiplied by the vertex color so that, only the tips of them move. So that's another way that you can deal with the foliage with the Pivot Painter. These ones here are done the exact same way that these are done. They've got their own individual clumps, which are in the secondary polygroup, and then the leaves are vertex painted from root to tip, and that's why we get this little jiggle around the edges of the leaves. This one here is done the same as this example, where we did 3D pivots for, the individual leaves and whatnot. This fern is a bit of an outlier, because it doesn't need to be three-dimensional, so we can use the fern mode, which only does one UV channel. It saves a little bit of data and whatnot, but it just has just the tips, and it uses the origin as the root point. All right, lastly but not leastly, you might want to be pivot painting your grass. Now, grass is a bit easier. If it is like simple, short grass, then all we need to do is right-click on this. We go Scripted Asset Actions, Pris Pivot Painter. We don't have to assign the default polygroups because we can just click this tick box here, which will auto-gen polygroups. We're going to assign UV pivots as grass, which just uses one UV channel with a pivot XY at the base. Starting UV channel 2, we do want to paint vertex color, and if so, what channel? The R channel. We don't want to do absolute units, so we just click OK. Now you can see that this has been painted from root to tip. And if we go to the root locations in world space, or let's just get our text coords, and we'll go to channel 2. If we put that into the base color, you can see that from the origin point, it's saying, yeah, this one is in, red direction and negative green direction, and these ones are in positive both directions, and these ones are in negative both directions. So that's another way that you can just check that things are actually working. Now, another funky little use case is if you wanted to have like debris, like interactable debris, so like fallen leaves and sticks and dead grass on the ground. There's also a method for that. So we right-click this, Scripted Asset Actions, Pris Pivot Painter, blah, blah, blah. You can auto-gen polygroups. You can assign UV pivots. You want to do these as debris, which is similar to the grass, but it will get the center of the cards to use as the pivot. And it can also vertex paint them from center to not center. So debris, starting UV channel 2, may as well paint the vertex color, blah, 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 click OK, and it just went ahead and did that. If we look at the vertex color, then it should have painted them from middle to outer. If it has polys in the middle, which I don't think these ones do, I think they're just square cards. So then if we hit play, we have a look at this one. You can see that these leaves they're not like distorting like they would if we were using like individual vertex WPO. They're all moving like as a group. So there's no like distortion when we, shuffle them around and whatnot. The wind does distort them. So you can see the difference between when they are per vertex, which is, they kind of expand and do weird shit, versus when we just move them with our feet, where they're actually using the pivots. So that is basically the script explained. So far we've covered what pivot painting is. We've covered how to use the Prismatiscape Pivot Painter plugin script with a few examples and whatnot. Lastly, we're just going to kind of brush over how I implement the pivot stuff in the materials in the Prismatiscape plugin. So let's just jump back in. And if you are in the test level, you can actually click on all of these ones here, and they have an example material. All of these examples here use what I call easy mode material functions, which are just presets that I use in Prismatica. So, for example, if we go into the fern and we double click this, and we double click this, and now we're in this material, what we want to look for is the Pris Large Flat Fern WPO. And so we can double click this, and this is all of the WPO logic for a large flat fern. First thing you'll notice is that I'm sampling the pivots twice, which you might think is like, why do you need the pivots twice? And why are you sampling the interaction textures twice each? The reason for that is because if your fern is really big, let's just say it's like this big, right? You need to like quadruple sample this fern. But if we just go to this, you'll see that we can interact with it here, so about 40% along it, and then also again at 75%. But in between them, we're not getting any interaction, So the reason that we double sample is because a reasonably sized fern, it is still very large, but the interaction bubble around a character is usually like a radius of 30. So even if we go like in between these interaction points, one of them's at 75%, the other is at 40%, we can just get the average between both of them and apply, the rotation based on that. So this is kind of what gives the fern a more bonular feel, or a more skeletal feel, because we're sampling the interaction at multiple points and getting the average value of that. So that's why, like, if I'm near the tip, then it moves, or if I'm near the middle of it, it still moves. And then if I go right in the middle, they all squish downwards, because we can also sample the object pivot point to do some funny stuff. So, yeah. So again, just running through that WPO function, we get the interaction bubbles, and we use those RG values to to push with the foliage pivot pusher, which just pushes foliage sideways based on the push amount, which is from those interaction bubbles. Now, the pivot point is just the roots location, and the pivot direction is just the pivot direction, which is the roots minus the tip normalized. So we're getting the direction or the color of our bubble, and we're dotting that against the world space direction of the fern, and that's how we know which way to rotate it, based on, you know, the strength of that dot product. If we approach it from this way, then it won't, you know, it won't bend until it detects, you know, a sort of directionality. So also going into the pivot pusher, we just add the wind vector, the wind velocity, and so the wind will bend those fern leaves out of the way, you know, the same way that the bubble would. Then down here, we have the foliage wiggler, which, as it says on the tin, wiggles foliage. We put in the pivot point, which is the root points. The random seed you can just get from the pivot data. It essentially just uses the tip locations and adds them together and then fracks that. And that just gives us a random 0 to 1 value. That's just so they don't all wiggle the exact same way all the time. And so going into the foliage wiggler, we have the interaction bubble velocity. So basically, as we move around, our bubble will kind of write a velocity that like fades out quicker. So that will cause it to jiggle. And then we also just use the wind velocity again to make it wiggle. So if we go back to the ferns and we, you know, let's say we like push one out of the way, you can see that it isn't jiggling more than its ambient jiggle from the wind. But if I jump, you can see that it will like jiggle a lot more. Same as if I just like run past it, it will jiggle kind of like crazy. So now if we use the wind, you can see the wind moves it out of the way and also causes it to jiggle. So that's how all that works. All right, we'll go through one more example. This one is probably one of the more complex ones, and that is the big single stemmed bushes WPO example. So if we actually jump into here, you can see that this one's a bit long. It's a long boy. And it's doing some, I mean, the inputs are quite simple, but it does some funky stuff here that will kind of take some MS Paint diagrams to explain. So, first of all, we are sampling the wind and the interaction bubbles at the pivot point. So at the origin point of the mesh, which is coincidentally where that middle stem is. Then we are doing a foliage wiggler based on the wind and the bubble velocity. So that will jiggle, or sorry, that will wiggle the entire thing. So when we bump into it, the whole thing wiggles around. And when we blow wind on it, the whole thing wiggles around like that. Then we also do this, which I'll talk about in a second. But for each individual leaf, we use the pivot pusher, which we saw in the fern. So that rotates things, you know, around sideways. And into the foliage pivot pusher, we are putting in the wind and the bubbles again. But they are sampling the tip locations of the individual leaves. So if we go here, we go to these leaves, we go near the tip, you can see that they are now interacting, you know, based on the tip location. Very cool. And you can also see that, yeah, they jiggle around when they're affected by the wind, or if we run past them, they'll be pivot pushed independently. We also do the same thing with the jiggle. So the bubble velocity, so for the wiggler, for the individual leaves, we're again using the bubble velocity and the wind, and then they all just get added together and whatnot. So this is where it gets a little bit more complex. We have this function called the foliage pusher downer, which is basically made just for these types of meshes. And this is what pushes the foliage down. So you can see these leaves, when I get on top of them, they get pushed down. But you can see they move sideways, but then they get pushed down as they kind of move across the character. Like this. So they kind of look very bonular. And this is where things get a little bit extra. So over here, we have this foliage bender. So here we have the foliage bender, which bends the overall bush side to side based on, you know, the interaction bubble and the wind. And we add that to the wiggler. But then something that we're doing down here is we're adding the WPO from earlier to the tip location. So we're essentially saying sample the textures from where the tips would be if this WPO was already applied. And then we do our pivot pusher and our wiggler. And then after that, we add that WPO onto the tip locations and then sample the interaction bubbles from that point to then do our foliage pusher downer. So you can imagine, here's our bush like this. We've got the foliage, you know, all the leaves and stuff. And so this is saying, hey, this is where the tip is. This is where we want to sample the texture from. However, if the bush was bent over like this, then that pivot point that we're sampling from needs to move. So we have to apply the WPO to that pivot point so that then the sample knows that it is occurring here. And then also when the leaves get bent sideways, then we also want to sample it from there for the foliage pusher downer. Basically, you can add the world position offset to the pivot points to essentially like sample from the visual location rather than their real location. So another example of this is in our clumps. Now, one thing that happens with these clumps or with the flowers is that we can permanently or semi-permanently depress them with our feet. So you can see these get bent over like that. But then we sample the bubble from the tip. So you can see here, they still get interacted with when they're fully bent over in that direction. The way that we do this, and this is, it's similar, but this is actually more accurate to do it this way. We sample the trample deform, which is like the feet hitting the ground, you know, like the grass deform, essentially. And we then do a foliage bender, which has the same settings as the foliage bender over here. So you can see that the max bend angle is 66 degrees. You just got to make sure that they have the same settings. But over here, instead of bending the world position, which is the individual verts of the mesh, we're actually bending the tip locations around their pivot points. So this might be going way over your head, but I figure it's still worth explaining so it's like, you know, in the back of your mind. So we essentially do the trample deform, we do the bender over here using the trample deform. So inside our Pris _ small flowers WPO easy mode function, we are getting our pivot data. We've got our roots here, we've got our tips here, but we are rotating the tips around the pivot. So in this case, rather than just adding the actual WPO, we're actually just rotating the tip locations themselves. And then that is then our new tip location where we then sample the wind and the water and the interaction bubbles. So this bending here is being done by the trample deform because that's kind of like a permanent, you know, permanent deform mask. And then over this side, we have the actual foliage bender, which is bending the world position. So the actual, the actual vertex locations. So this is what's actually doing the real WPO. But then over here, this is just bending the pivot points using like basically the same calculation. Same, but different. So then this bender here is comprised of the wind, as usual, also the interaction bubbles, but these wind and interaction bubbles are being sampled at the location of the new tip location. But then we're also adding the trample deform sampled from the pivot location, which then gets added into it and, does all its usual stuff. So if we actually look, let me just change these to be trampled like, 90 degrees or something. So these have been trampled all the way down. That trampling is being sampled from the root location. But then when we go and walk past them, they move being sampled at the tip location. So hopefully that makes some sense. It is a little bit advanced and, borderline unnecessary, but I just figured it's a nice touch that, even if some flowers or some grass or some bushes are like, completely bent over, we still want them to feel interactive, which would then require them to be, interacted upon at their tip location. So this is why sometimes you'll want the root and tip specified, even if it's something simple like grass, where, you could just get away with painting the root only. So that is the Prismatiscape Pivot Painter script, and also what is pivot painting, general overview, and also some examples of how we can use, pivot painting to achieve certain effects, and how we can like rotate existing pivots to then sample at the visual location of where this pivot would be to then do the interaction in an extra very complex, but hopefully this sort of points you in a few directions. And also there is always the easy mode functions that I've made for my project. So if you use the Pivot Painter, in the way that I've kind of showed you earlier, you can just try out all the different ones and find one that works. And I'll be adding more and more of them as I go, as I have more different foliage types to make WPO functions for. So I hope that this got you started. I hope this gets you far enough along that you can, figure out the system. I know I haven't done a great job at explaining it, because it is all convoluted, to say the least. So thanks very much for watching. Hope you have fun with the Prismatiscape plugin, and with that, we say goodbye. Goodbye.